to review with me linear equations in two variables. So this is directly from College Board SAT preparation guide. So in this lesson, basically what you are learning is systems of equations. If you remember in Algebra 1, systems of equations, this is practically what you're doing. There will be a Desmos demonstration on these types of problems, but that is in a future video, which will be Desmos only for the whole algebra content of this module for your SAT review. Okay, these two are linear equations. Next, in order to solve for x and y, you need two equations that intersect each other, and that will give you the solution. And the solution of a system of equation is the x and the y coordinate that satisfies both equations. They cannot not intersect, they must intersect, because that's where they both share the same x value and the same y value that makes both equation together true. Okay, so there are three methods, and if you remember those three methods, there are graphing it, there's substitution, and then there is elimination. You can do whichever one. So because you do have access to the Desmos that will be embedded into your digital assessment question item successfully with Desmos. But let me go ahead and just show you how to do it by hand. Now I'm not going to do all three. I will do the graphing part in Desmos, but if you had to do the graphing part, you would put each of those, 1 and 2, equation 1 and 2, in slope-intercept form, or find the x and the y intercept for both of these, and then graph it, sketch a graph, and then circle where you think your coordinate is. But here's the thing. Graphing is not the best by hand because you don't get precision or accurate coordinate by graphing by hand. So that's the beauty of having Desmos. Okay, so Desmos does that for you. Again, that'll be in the Desmos video where I'll do all of that for you. So the next one is substitution. So substitution is basically turning one of the equation into slope-intercept form and substituting it into the other equation. That's my personal favorite. I don't really like elimination so much because you have to modify it or manipulate both of them to cancel out an x or a y pair, but I'm gonna go to substitution for this one. Okay, and I'm gonna pick one of the equations, and I will go ahead and just pick the first one. Doesn't matter which one. You can go ahead and try the second one. Slope-intercept form is y equals mx plus b. Okay. So for the first one, in order to put it into y equals mx plus b, the y needs to stand alone. Alright, and then I'm going to go ahead and divide by 2, and I'm left with negative 2x plus 2. Okay, so now I went ahead and put the first equation into slope-intercept form. So now I know what y is. Y is negative 2x plus 2. So I have 19. I'm going to plug this into the second equation. So I have 19x plus 10. My y is negative 2x plus 2. Close it, and I'm going to finish off. So all I did was substitute this y for what y tells you that it is, which is this right here. Now, as I showed you before, and as you remember, you're going to have something called distributive property process over here. So 10 times negative 2x is negative 20x. And 10 times 2 is positive 20 equals 14. Okay? Now we're going to go ahead and combine like terms. This and this here together is going to be combined. That's negative 1x. And we got this plus 20 equals 14. And we're going to figure out what x is. So we need to get rid of this 20 so we can isolate our x. Negative 20. All right, so I went ahead and substitute x for 6. And now let's go ahead and figure out what y is. So we have 24 plus 2y equals 4. Subtract 24 on both sides of the equal sign. We have like terms over here. Now I have 2y equals 4 minus 24. That is negative 20. And divide by 2 to isolate my y. We know this is 1, but we don't write 1y. And negative 20 over 2 is negative 10. So that means x equals 6 and y equals negative 10. So when you get to the Desmos portion, you will see the graph for this equation and a graph for this equation. So you will have two graphs. And then you will look for where it intersects, and you will have this as a point. And that point will be 6, negative 10. And that's your solution. Okay, so that is the solution. That's where both equations intersect, and that is the solution. So that means if you plug in x, 6 for x in both equations, they both will balance, and their y's will be negative 10 for both equations. If you plug in 6 and negative 10, they both will balance. Okay, it will be true for both equations. All right, guys, so keep practicing linear equations in 2 variables, and I'll see you in Desmos.